Hello everyone and welcome to a brand new video on the ascending pathways, or also called sensory pathways. So what we're going to be looking at in this video, what we want to focus on is what kind of neurons are available here in the sensory pathways, and what we mean by that is what is called the first order, second order, and third order neurons that would be located there. We're going to look at where in a spinal cord cross section you would find the tracts or pathways. We're going to look at what is carried by each pathway and how the pathway gets to where it's going, its final destination. So the real first order of business is to look at a few things about what we refer to as first order, second order, third order neuron. And as we do that, I will mention a little of that is that I'll use this diagram for two things. First order neurons are the sensory neurons. That's going to be the one who is carrying the sensory information from a sense receptor. So let's say I've got a sensory receptor here. It's been stimulated and it synapses, sends its signal to a sensory neuron, which resides in the dorsal root ganglia of the spinal cord, and that will arrive to the CNS. Now, generally speaking, remember that what these neurons are doing is they're coming in to the CNS, to the different sensory nuclei, like the posterior gray horn, for example. Now, the other ones that we want to make sure we see are the second order neurons. This is an interneuron. So an interneuron will synapse here and go maybe cross over here or travel upwards from here, but it is an interneuron. The third, so that would be our second order neuron. The second order is an interneuron. Now, the last neuron here is going to be what is referred to as the third order neuron, the one that will take the information from the thalamus to the appropriate part of the cerebrum in the postcentral gyrus. So let's clean this out and take a look at where these things are. So let's take a look at some of the particular pathways. Okay, so the ones we're going to be looking at are the posterior column pathway, the Spinocerebellar Tracts, and the Spinothalamic Tracts. So let's take a look first at the posterior column pathway. Posterior column, of course, is found entirely here in the posterior white column of the spinal cord. If we color that in, we're going to notice that this would be the area where the tracts would be located, the posterior column pathway. Now, posterior column pathway is made up of two distinctive tracts, what is called the fasciculus gracilis and the fasciculus cuneatus. The fasciculus gracilis and cuneatus can kind of be divided up about here, where we would see the gracilis here, fasciculus gracilis, and over here the cuneatus. For the fasciculus cuneatus and the fasciculus gracilis. Now, let's do the spinocerebellar tracts. Spinocerebellar tracts are primarily located here in the lateral white column of the spinal cord on both sides. It consists of two distinctive tracts that are also making that up. So if it's shaded in, all of this would be that area. There's an anterior and a posterior portion of that, where the anterior is more located here in that area, and the posterior is the one that takes up the majority of the space. Also, there would be a lateral spinothalamic tract, and the lateral spinothalamic tract primarily in this area lateral spinothalamic tract. Spinothalamic because we're going to see that the information, the second order neuron, goes from the spinal cord to the thalamus. So this is the lateral spinothalamic. And then we're going to see an anterior spinothalamic as well. The anterior spinothalamic tracts are right here. So we'll see an anterior spinothalamic. And these are the tracts and pathways that are traveling up the spinal cord to go to the brain. So what we're going to do is take a look at each one of these, and on the drawing that I've used, we've got a coronal section, a frontal section of the brain and midbrain on the top. Then at the bottom we got a cross section of the spinal cord. And what we're going to do is look at what each of these things carry. So if I've got a sensory receptor here, a receptor has detected something. What is this one detecting? Other things that this guy is detecting, it would be fine touch, or to say 2-point touch, fine touch, or 2-point touch, vibration, also pressure, and proprioception. Proprioception is knowing where your body's position is in space. So the receptors here are going to send information to fine touch, vibration, pressure, and proprioception. So that's what it's detecting. That's what it's going to tell me about. So from the receptor who detects that, a neuron is going to travel called the first order neuron. And the first order neuron is going to have a cell body is residing in the dorsal root ganglia. And this one's going to do something interesting. He's on a spinothalamic tract, but he's going to be carried by the posterior column pathway, who has two separate parts, fasciculus gracilis, fasciculus cuneatus. And this neuron, when he enters into the spinal cord here, he does not cross over here. He's going to go cross over at the midbrain. So this neuron is going to go up into the posterior column, posterior white column of the spinal cord, and travel all the way up to the midbrain area. So we're going to go to the midbrain, where it's going to synapse with a second order neuron. So the second order neuron is residing here. And this second order neuron is going to cross over, and it's going to an area of the brain called the thalamus. It's going to the thalamus. And it's going to the thalamus on the opposite side that the sensory receptor detected the information on. So it crosses over at the midbrain. And from there, a third order neuron is going to pick that up in the thalamus and send that information to the correct part of the sensory cortex at the post-central gyrus. That's where the primary somatosensory cortex is on the cerebral cortex in the brain. So we could see our first order, our second order, and our third order neurons, where they are, what's going on with them. We could see that the crossing over occurs in the midbrain, and the posterior column pathway, we said, is made up of two different smaller tracts. Now, the fasciculus gracilis is one that handles lower half of the body, where cuneatus does upper half of the body. And that's really all it is. Imagine a dividing line there where you would have fine touch, vibration, pressure, and proprioception coming in. If this was the right side of the body or here, it would end up at the left cerebral cortex. So there is a crossing over, a deconsation that occurs is an important thing to also know about these pathways. So as we see that one, let's take a look at the very next pathway after this. And the next pathway we're going to look at is going to be the anterior spinothalamic. Anterior spinothalamic would be located generally about here on the spinal cord, is where you would find the bundle that goes up to that. Now, the sensory receptor that's here, what is it going to be telling me about? Well, first thing it's going to tell me about is crude touch and pressure. What do we mean by crude touch? Just very basic information about it. And then some pressure. And this receptor, the first order neuron, is going to arrive here. It's going to have a neuron cell body in the dorsal root ganglion. It is then going to enter into the posterior gray horn. Since this is somatic, it's going to be actually in the posterior part of the posterior gray horn. So let me be a little bit more accurate with that. And it will synapse with the second order neuron. Now, the second order neuron is where the spinothalamic gets its name. It crosses over at the level of entry and takes the tract up to the other side here, to that thalamus. And the thalamus, being an important nucleus, possesses the third order neuron who takes them out to the final destination. So we have our first order neuron, our second order neuron, and our third order neuron. And this is the anterior spinothalamic tract. So what do we see about this? It carries crude touch and pressure. It crosses over at level of entry. Its third order neuron comes to the primary sensory cortex at the post-central gyrus. And that is important about what they carry, where they cross over, where they end. And then I will give you an important thing at the end and walk you through something very crucial at the very end about whether or not you're aware of it. So now let's look at our sensory pathway called the lateral spinothalamic. Now, this being lateral spinothalamic, it's located more on the lateral side of the spinal cord, kind of located here next to the lateral gray horns. And so we're going to draw that tract there. And we're going to make sure we know that there's a sensory receptor telling us about pain and temperature. I'm going to abbreviate it as pain and temp. Pain and temperature is what it's telling me about. So this neuron, sensory neuron here, is going to carry that information in to the dorsal root, where there's a cell body in the dorsal root ganglion. It's going to come to the posterior part of the posterior gray horn, where now it synapses with a second order neuron. Now, the second order neurons you will see crossing over at level of entry, where it comes up to the thalamus. And it comes to the thalamus on the opposite side it came in on, to say contralateral. And then you're going to have your third order neuron take it out to the post-central gyrus, primary sensory cortex. Now, it crosses over at level of entry, carries pain and temperature. We will see that it is coming to our cerebral cortex, which is going to be important here in just a minute. And I will go back and look at some other things. Now, the very last one that we're looking at is called the spinocerebellars. On the spinocerebellar, there's two. There's a posterior and an anterior spinocerebellar. Now, the anterior one, I'm going to do the anterior one here, and the posterior one back here, and try to leave a gap. Same thing here. Try to leave a little bit of a gap so I can make a point here when I do something very important. Now, what we're going to do with this guy is we have a receptor. These receptors are things like Golgi tendon organs, things like that. What are they doing is tendon stretch and proprioception, or unconscious proprioception and tendon stretch. Tendon stretch. And unconscious proprioception, where my body is in space. Unconscious for balance. Now, why is it unconscious? Let's take our neuron here and bring him in. Here we are with his neuron cell body. He is going to come in to the posterior gray horn. But we're going to do the same thing here on this side with a receptor, bringing a neuron in with a cell body here. And he's going to come in. Now, one of these is going to be, they're carrying the same information from Golgi tendon organs. Apologize for my lapse of tongue there. And looking at my joint capsules and monitoring those things. Now, there are two pathways that are associated, two tracts, anterior and posterior. Anterior crosses over. If this one here were to be on this side, the anterior spinothalamic, he will cross over and go up to the cerebellum. Hence, spinocerebellar, because the second order neuron goes from the spinal cord to cerebellum. But this one does not have a third order neuron. And the anterior crosses over. And you're probably wondering about the posterior column pathway does not. So posterior column pathway, being that it does not cross over, will stay on the same side. So if this happens on the other side of the body, it all looks the same. That way we would give information to both parts of the cerebellum. Because it goes to cerebellum and not to the cerebrum, you're not aware of it. You're not consciously aware of it. Your body knows to do something with it. Your body will use this information to adjust tension of muscles of the descending pathways, to adjust tension of muscles for balance. But if you happen to go here to the primary, the post-central gyrus primary sensory cortex, you are aware of it. Your body will know. You'll consciously be aware of it because conscious information goes to the cerebral cortex. So I really hope you found the video helpful, walking you through the pathway and some things about it. I know my drawings aren't always the greatest, but I really hope that it helped you to visualize. I hope you take time to do this with me, to draw out the outlines of the body, of the simple drawings that we did, and then draw and color in with me to get a better understanding of the neuroanatomy, and then to take these neurons and draw it in different colors and label it as first order, second order, third order, knowing where they cross over, what they carry, and where they end. These are important things in neurological testing. So this concludes my video on the ascending or sensory pathways of the body. I really hope you liked it, enjoyed it, appreciated it. Let me know what you would like to see in future videos. Let me know what you thought of this video. I want to make my videos better, so let me know what I can do to improve. Let me know future topics you would like to see. And always don't forget to subscribe, to like, to comment, and hit that notification bell so you don't miss a single video. Thank you guys so much, and I thank you for watching.